Welcome to the Math Record. Today we'll be covering surveys, observational studies, and experiments. This video will cover Chapter 1, Part 3 of our statistics class. Okay, let's begin with surveys. There's a lot of them. A survey is basically a small group of individuals that represent a larger population. So for surveys to work, we have to randomize it. So they have to be random. So, like, you can't just, like, choose, like, 5 people into your survey, like, on purpose, like, you choose, like, 5 of your friends. It has to be, like, 5 people from a random population. Sorry, I don't know. I delete that. Random. And the other one would be sample size. So you have to have a really good sample size. As I said before, it's gonna be, in our previous videos, it's represented by n, which is the amount. So, for it to have like a good survey, you want as much people as you can, because what's the effectiveness of a survey if you have 5 people versus like say 50 people? You get more opinions, and that means less bias occurs. The most basic sample that we're gonna be using most of the time usually is a simple random sample, which people usually refer to as SRS. Um, it's basically you assign everyone like a number and you choose randomly while we ignore repeats. So what this means is that let's say you have 5 people, right? And you number them 1 to 5, right? And then you want to just choose 2 people, right? So you go through like a random number generator and you get 2. And then you go through it again, you get another 2. You don't count 2 again. And then you go through it again, you get 3. So that's how you get like randomly a sample of 2 from a 5, which is called a simple random sample. Just assign everyone a number based on how many like people there are. So like there's 30 people, assign numbers 1 to 30, or like 0 to like 29. Like it doesn't matter. It's basically you just assign everyone a different number, and then you choose like numbers while you ignore those repeats, so you don't get like double twos, because you can't choose the same individual twice. So that's a simple random sample, which you're going to be using a lot in experiments usually, because they're the most simple, but they're also the most effective. Um, and then there's stratified. There's stratified sampling. Oops, sorry, forgot the T. Stratified samples, which um, which is basically a random sample that takes into account proportions of populations. So let's say the population of like some kind of town is like 40% male and like 60% female, right? So if you had to choose, if you want to use a survey of 100 people, right? Your N is 100, then you had to choose 40 random males and 60 random females. And that's what stratifies means. You just choose it based on the the male based on like the proportions of the males and females. Because like if you do it randomly without regards of the percentage, maybe you could get like 55 males and like 45 females, which doesn't make sense at all, because then you have 40 and 60. And you want to get like as much bias out as possible. Because that's basically for samples. You want to get rid of bias. Because you don't want like because your bias occurs like let's say you choose your friends to do to answer a question rather than like strangers. You know, the strangers might represent a whole population better, while your friends have like more unique characteristics that you like choose them for, and that's why they answer a question this way. Um, the third kind of sample is clusters, which is cluster samples, which basically you split a population into smaller groups and you basically just choose one group. So imagine you have 50 people, but you just want a group of 10, right? So you divide each of the 50 people into like into 5 groups, right? Each group has 10 people, right? And then you just randomly choose like a group. So you choose like this group. And that's called a cluster sample. Usually this works like for like really large numbers. So let's say you're like there's 40 million in a population. I mean, yeah, 4 million in a population, and you want to get like 100,000. Then you just divide by like 40, and you basically get you have like 40 groups, and you just choose one of the 40 groups to get like a thousand sample basically. This works like really well with large numbers because usually like since there's so much people, it kind of just like all the bias kind of like drowns out. And after cluster sampling, there is systematic sampling. Matic, okay, the M. Um, Systematic sampling is basically you just gather a sample through a set system. So let's say like someone's going through a store and you want to get their opinion of like what is like the best clothing type. So you just like instead of like asking everyone that goes through, you could ask every single fifth person that goes through. So that would be called a systematic sample because you're using like some kind of system to get through it, you know? And the ones that like you to combine all of them, you usually just call it multi-stage sampling. It's self-explanatory. Basically, you just put like if there's two or more methods to like gather your sample, like if you use stratified sampling in SRS, then you're gonna be using multi-stage. So that's basically like the general like over scope to like have two or more samples. And then the samples that we usually don't like to take, these ones you usually don't want to do. There is voluntary sampling, which basically is that like let's say you send out a poll and the people that answer are gonna be in your survey. So this is bad because like people with strong opinions are usually the ones that give like an answer because usually people might be shy and they don't want to give like answers. So then they might not be in the poll. So their wishes might not be heard. And that's why the people with like the more extreme like views like are more likely to like respond for voluntary samples. So usually those don't work as well. And there's convenience sampling, which is basically sorry, convenience samples, which basically like going back to like your friends example, the friends example, like it's better to like it's more convenient for you to like gather a sample using your friends and families because like they might have a specific answer that you would like to hear. But it's better for you to even though it's not convenient, it's better to like give from a random population. And then the last one, which is kind of like a survey, is a census. It's basically asking everyone. So this instead of doing a sample, it's gotta be the entire population, right? So you're gonna be asking everyone for their opinion, and you get it down. Usually, you don't want to use a census because it's kind of costly. It takes a lot of time, and usually like it changes. So if you take a census in one year, you have to take a census in another census in a different year. So it's way too costly and it takes too much time and it just changes too much. So usually you just use a sample to represent the whole, even though sometimes it's not as precise. But it'll be like a good approximation for you to use and it'll be fine. So basically, you take all these samples. So you use these different samples like SRS, stratified, and like systematic multi-stage, just so you could like reduce bias. So bias is bad. You really don't want any bias, but it's sometimes just unavailable. What you want to do in stats is that you want to reduce the bias as much as possible. So some types of bias would be like undercoverage. which be like if you're using not as high n size or n is very small, so you can't really like get a good like a good read of like an entire population based on your sample. And then there is response bias, which is like shown through like the voluntary samples, which is basically because of as I said before, that people with more extreme like thoughts would be more. I mean, not thoughts. Let's say more extreme opinions would be would give like the answers that like they wish to, while people are more shy won't do it. And then opposite of that, you have non-response bias, because people that don't want to respond might give a different answer and might skew the data. So any single time that you ever see like you think a variable might be skewing a data, it will be counted as like a bias. So sometimes you just have to put this in context. Everything has to be in context all the time. So next thing we're gonna be talking about is observational studies. Okay. This basically is that you don't give people choices and you only like observe the population. So let's say you are out on the streets, right? And you want to observe how many people like pass this like how many cars like go through this street at like 10 a.m. versus like I don't know 5 p.m. because it might be there might be like there might be a trend between like the top when the time is and when people are like less likely to drive during that time because they get tired. So that will be an observational study because you don't give them choices. You basically just observe the population and see what happens. So that's observational studies. And the next thing is experiments. This is the one that you're gonna be learning a lot. This is basically is what experiment is like basically from science and stuff, but it's basically how to manipulate choices that you're gonna be giving to your subject, so then you can observe like those subjects in general, so you could like sample those populations basically. So subjects, the subjects are the people we experiment on, right? Experiment on. So we want to like we want to see if like some kind of medicine works well. So our subjects would be like our patients. And then experimental units. These are basically anything else. So other than the subject, everything else is experimentals. So those are the others. And then there are levels. Levels are basically like what the different factors are tested upon. So like the factors, like the amounts. So let's say you're playing a video game, right? And there's easy, hard, easy, medium, and hard. So since there's 3 levels, easy, medium, hard. That's basically what it is. There's 3 levels. And then there's treatments, which basically like puts in combinations between like multiple factors. So it's basically combinations. So let's say like for that video game, right? Each of the easy, medium, and hard has is from 1 to 3 stars. So there's 9 different treatments because like there's easy 1 star, easy 2 stars, easy 3 stars, medium 1 star, medium 2 stars, and etc. Right? So there's 9 of them because there's 3 of the levels and 3 of those stars for each of those levels. So that's 3 times 3, which is 9. So those would be counted as the treatments. Usually when there is an experiment, there isn't a level most of the time. Usually it's just basically treatments. Because like usually the examples would be given would be like the medicine kind. So it would be like, does treatment X work, treatment Y works, or like or they both just work equally amount. So how do you design an experiment? There is 4 things you have to do. There is control, which basically you have to control the external variation from each treatment. So basically, you don't want like a lot of bias to occur. Like when we talked about in samples, you don't want to have a lot of bias. So you want to like control all those external variations. So then they don't be. So then the only thing that usually affects it is like the in our example, let's say our treatment X and our treatment Y. Those would be what we're gonna want to like test on, and we don't want something else like maybe someone's age or like maybe their chemical compound in their body or like their BMI or like BAC or like concentration might like change like how the medicine might be affecting each people. So you want them to be like as closely like together as possible. So for control, there is usually you always want to put a control group. A control group is basically just the normal group. So if you're given someone a treatment X and a treatment Y, you have to have a group that doesn't get any treatment, right? So then you just want to observe how like this control group is related to other ones because it might be like let's say the like treatment X works for 25% of the patients, and treatment Y might work for like 10% of the patients, right? But then you think those numbers are low because it only works for 25 and like 10%. But maybe the control group it shows that like that the if you don't give them any treatment, only like 2% of it worked. So then that 10% and that 25% is actually really high. So it might be a really good treatment then. So you always want a control group to compare them against. Because just basically having like treatments doesn't tell us if it's good or not. We have to compare this to like other things to see if it's good in comparison to anything else. Because we just want something better, you know? So usually the fake treatment that we always give them is called a placebo. So it's basically just fake. So like if if you have like if you watch The Matrix, basically it's like the red and blue pill. But what happened if you like eat the red pill and kind of does nothing, you know, or the blue pill? So it's basically like a placebo. It does nothing, but it seems like it does something, and that's why people like always talk about like the placebo effect, which says like if you if you inject someone with like a vial of like I don't know, like some kind of happiness drug, and they become happy all of a sudden, even though like maybe the the vial was like basically nothing. You know, it's called a placebo. So it just wants to like know if it actually affects them. Because usually when you put a placebo, you're gonna be observing their health. Because while the behavior might not what might change because they think it might be happening because of the placebo effect, you could actually see what's happening, measuring like their health and their composition of their body. So that's why you need a control group. So placebo control group usually goes together. And something else is called blinding. So um you want to use blinds so then like people that analyze the patients and the patients themselves don't know what treatments they have because like they might react differently based on the treatment, you know? So let's say you have a control group and you have treatment X, and you set that you want to test if treatment X is better. So if you tell someone that they're taking treatment X, they might act, they might like feel based like a placebo kind of idea that they have that they might be benefiting more because they're taking a treat because they're thinking they're taking a treatment when it really might not be happening. So you want to use blinding so they don't know which kind of like medicine they took. So there's two of them. There is a single blind. So it's either when like the evaluator or the subject the patient doesn't know the treatment. Um, so if the subject doesn't know, then it's usually when the subject doesn't know for it to be a single blind. Because then like the evaluator can evaluate them and they don't know what the which one they took. And then there is a double blind. A double so for single blind it's usually just the subjects. For double blind it is both. So it'll be the evaluators and the subjects. So then you, as the researcher, doesn't tell the evaluators and the subjects which one they took. You just ask the evaluators to give this pill to the subject, and you ask them to like interview them to see how they like feel, because the evaluators might be like approach someone differently when they are taking treatment X versus like treatment Y, and you want to reduce that bias. So that is one out of the four things that you have to use to describe an experiment. The next one you want to do is that you want to randomize it. It seems pretty obvious, but you always have to do it. You you don't want to have like 50 people you just chose from your like chose purposely just so you could like take the like treatment, because it might be like different, you know. So you always want a random. It's really self-explanatory, but you basically always just want to randomize everything. And replicate, you always want to be able to replicate the experiment, because if you have one result from an experiment, it doesn't count as data, because it just counts as one result. Because if you could replicate it, then there might be some kind of association. So it should be able to be replicated, because it might just have been a fluke, or your sample might just have been like really bad. Um, and the last thing is blocking. Blocking means to stop a variable from affecting the experiment too much. These variables are usually referred to as blocking variables. So let's say like going back to a treatment example, let's say you think that gender might like affect the um the uh the experiment, so you block it. So you because like there might be like a noticeable difference between like the composition of a body between a male and a female. So you want to see if the treatments are affecting them like in different percentages, you know. And maybe something else would be like blood alcohol concentration, right? So you think like if someone has a higher like BAC, they have like a lower chance of like having the treatment helping them. So you want to have those as like blocking variables. So you want to block it based on gender, based on size, based on like just any external variables that you want to minimize bias in. And that's what you use for blocking. But basically, everything that you do in this, if they're giving you a situation, you want to do it in context, like how I did with the experiment. You want to do everything with context. So you want to say block, not because block. You want to say I'm blocking this experiment because of external variables. You have to say I'm blocking this from external variables like BAC or like weight. So you have to do everything in context. Everything in context. And then there is those variables called confounding variables. Sorry, that's an N. Confounding variables, which is like when one level of a factor is associated with another variable. So this would be like if you put like some variable x and some variable y, it might and then like they have a linear association going to the right and it's positive. It you might want to say that it's x is increasing as x increases, y increases, but that sometimes is not true. It might seem like x is increasing with y, but there might be another variable that we're missing that's gonna be that's affecting x, that's showing x is increasing with y. So sometimes it's just something we can't really like find, you know. But like it's just good. These variables would be called as confounding variables. There's nothing we could really do about it, but just to recognize that it's there and it's possible. And then other than that, there's lurking variables, which is basically a variable that makes it seem like another variable is affecting another variable. So it's basically the same idea as a confounding variable. There's just not much we could do about it, but as I said before, for compounding is you just have to like notice that there might be a possible reason why it's there. Because that's why every single time we have like a scatter plot, we can't say that x is like affecting y. We always have to say x is associated with y, you know? Because like let's say for like in case of depression, right? You we might think that like I don't know. This might be a fallacy. I don't know too much about depression. It might be because, like, let's say you put there's too much of chemical X, and that's why it's affecting. That's why depression is increasing. But in reality, like, there might be some other chemical called chemical Y that's actually causing it. But since chemical Y is occurring and it's boosting the amount of chemical X, then that's why it seems like chemical X is causing depression when it's really depression, really chemical Y. So that's basically a general idea of like how that works. There's not much we would do about it, but just to notice that it's there. So that's why we never say anything is 100% certain. We will say it's likely or is it not likely. So let's take for example, let's say you want to try like to determine if treatment X is better than treatment Y. So you're given a sample of 90 patients. So your subjects would be your 90 patients, right? Because those are the people that you're going to be taking the subjects are. And your factors would be treatment X, treatment Y, or it's going to be none. So it's only, there's not any like levels basically, because basically you're just kind of, it's either, the treatments are either going to be X, Y, or none. So those are your treatments. So none would be your control group. So, based on this, how you usually write it is that you have to put everything in context. So you want to go through each of the 4 points of how to do it, which is control, random, replicate, and block. And then you put everything in context. So you might want to say like you randomly assign each patient a number from 1 to 90, or like no patients like sharing the same number. So and then you randomly select like 3 different patients. So then you can't have like 29 patients into one treatment because like you choose like that number twice. So you have 30 different patients for treatment X, and then a different 30 for treatment Y, and then the last 30 for treatment for the one without treatment, which you're gonna give as a placebo. So the control group will be given that placebo, and then all the patients won't know which treatment they took, and the people that you choose to evaluate those patients, they also don't know what they took. So this gives them a double blind, and then and finally you just record the results, and then as stated before, you while blocking isn't like something you have to do, because blocking for it's when you're designing an experiment, you have to control, you have to randomize, and you have to replicate, but it's not necessary for you to block. It's not required for you to do it. It's not mandatory, but it's good to have. So, maybe you wanna do some blocking, like, based on, like, weight, gender, or age, you know? So you wanna just might mention that. You don't have to do it in your experiment, like, when they ever ask you a question. You just have to say it, like, what word, literally, that you have to, that you're blocking, that you could block based on, like, weight, gender, or age, because it might be, like, affecting some of the, variables and may cause bias. And then, finally, you could say that this experiment could be replicated using the exact same process. So that's basically how you like write and design an experiment. Because you have to write everything based on context. Because notice how I didn't say block based on external variables. I block based on age, weight, gender, etc. And I didn't say like you give you split the 90 people into different groups. I said I split the 30 people. I said I give each patient a number from 1 to 90, and I randomly select 30 for each group, you know, for X, Y, and Z. Because I don't want to be too in general. You want to be as specific as possible for you to design a good experiment. So basically, that covers like everything for our surveys, observational studies, and experiments. So in summary, in this video, we covered different types of surveys, observational studies, and learn how to design experiments. Thanks for watching, and I'll see you at the next math record.